Good morning, mathematicians. It is Wednesday of week 16, and let's jump in and get started. Number one says Professor Perfect shared 7 kilograms of catnip with her students last week. That was 1/8 of her total catnip. How much total catnip did Professor Perfect have, right? Well, remember what we're hearing in this problem. She shared this much, 7 kilograms, right? But that was only 1/8 of the total amount of catnip that she had. So really, we're looking at 7 as only a portion of her total amount, which really is a portion, 1/8 of her total amount. Now, we have seen this pattern to be true, that we can multiply our whole number in our denominator in division, right? And so we can do our 7 times 8, which is 56. Now, what does that 56 mean related back to the catnip and Professor Perfect? We know that it is 56 kilograms, right? That is the total amount that she actually has. Now, question two is about partial products. And we're looking at quite a big number. So you'll notice I actually put a little sticky note on here because I like to do this in one line. You might like to do this on a piece of lined paper, or you can even go and just kind of do it on the back of your paper if you're wanting to keep it in a line like I do. I love to see that nice and neat. Now, let's talk about what I've already written out here. We want to do 425 times 46 in partial products. Now, when that happens, when we're doing it in partial products, what we need to do is we need to take each part of 425 and we need to multiply it by each part of 46. So that's what I've done here. Notice the 425, I have 400, right? I have 20, I have 5. And the reason that they're repeated is because I have to multiply that 400 by the 40 and then that 400 by the 6, right? So I had to repeat that. Then I had to do the 20 by the 40 and by the 6 of 46. Then I did the same thing for the 5. I had to multiply the 5 by the 40 and then the 5 by the 6. So that's exactly what I've done here, right? When you take a look here, we have 2, 4, 6. We have 6 um, tiny problems. We would call those terms within our overall partial products expression. And the reason we have that many is because each of these numbers had to be multiplied by the 4 and the 6. So this 400 accounted for 2 of those terms. This 20 accounted for 2 of those terms. This 5 accounted for 2 of those terms. And that is going to lead us to our overall answer. All right, let's go ahead and jump in. We have 400 times 40, which again, the 4 times 4 would be 16. And then how many zeros do we have outside the basic fact? We have 3. So our answer here is 16,000. Now that is going to be added to this 400 times 6. Well, 4 times 6 is 24. And then how many zeros do we have outside the basic facts? That would be 2. Now we have 20 times 40. Well, 2 times 4 gives us 8. And how many zeros do we have outside the basic fact? That would be 2. Now we have 20 times 6, which, of course, 2 times 6 is 12 plus 1 zero outside the basic fact. Now we have 5 times 40. Well, 5 times 4 is 20, and there's 1 zero outside the basic fact. And here we have 5 times 6, which, of course, is 30. Now, look at all of those partial products that we need to add together. There are quite a few of those. You might want to come to the side and list those and add those, or you could think about and combine the ones that make those numbers that you're seeing mentally. But what you are going to find is when you add all of those together, it's going to lead to the answer of 19,550. So our answer to this question is that 19,550. Now we are ready for our third problem for today. We are multiplying some proper fractions. In part one of this question 3, we see 56, or excuse me, not 56, we see 5/6. And we're multiplying that by 1/3. We know that we can multiply the numerators, and multiply the denominators. And when I do that, I'll have 5 times 1 is 5, and 6 times 3 is 18. So our answer for this part 1 is 5/18. Let's go on to part 2. In part 2, we have 3/7 times 1/2. So we're only going to take a half of 3/7. I can multiply my numerators. I can multiply my denominators. 3 times 1 is 3, and 7 times 2 is 14. So our answer to part 2 is 3/14. We have one more part. This part 3. We have 4/5, and we're multiplying it by 5/8. We're going to multiply our numerators, multiply our denominators. We have 4 times 5, which is 20. We have 5 times 8, which is 40. So our answer to this question is 20/40. Oops. If you wrote this as 2/4 and half, that is perfectly fine as well. Of course, those are equivalent fractions. They stand in the same place of number line. All right, let's go to Denzel Washington. He is filling his 6 bathtubs with bubbles. Each tub requires 1/3 a bottle of bubble maker. How many bottles will Denzel need in total? So what we want to think about here is that he has 6 bathtubs, and each of those bathtubs are going to need 1/3. Each of those bathtubs are going to need 1/3 of a bottle, right? So we really are multiplying here because we're going to need this 1/3 6 times for bathtub 1 and 2 and 3 and 4 and 5 and 6. So here we can go ahead and multiply our, we know here that the pattern with multiplying a whole number and a fraction is to multiply the whole number and the numerator. So 6 times 1 is 6, and our denominator stays the same. So you could say 6/3, but I don't generally buy bubble bath in fractions. So instead, we could think, well, 6 or 3 goes into 6 2 times. So the answer to this question is that he will need 2 bottles, right? Remember the difference. When we are dividing a whole number by a proper fraction, we multiply the whole number by the denominator. That's in D, division. Now, down here, when we're multiplying, we have the whole number times the numerator. So that's the reason that that pattern differs. Our last question for today is Clint Feastwood has eaten 2/3 of his chicken bucket. He's eaten how much? He's eaten 2/3. He plans to finish the rest evenly over 5 days. What fraction of the bucket should he eat each day? So if he has eaten 2/3 of the bucket, how much does he have left to eat over the next 5 days? He has 1/3 of the bucket left, right? And that 1/3 of the bucket is going to be spread across 5 days. So we're looking at this as our situation here, right? We've got a third that's going to be divided out among these 5 days. We can think about that 5 times 3. That 5 times 3 is going to tell us that we need 1/15 of that bucket to be eaten each day so that it can last that long. So we're going to write our answer here of 1/15. That's what happens when we take a third and we break it into 5 parts. We end up with 1/15, which of course is the amount he can eat each day. This finishes out